Okay, I think it's working now. So hi everyone, my name is Neeraj Kumar. I'm a solutions architect at Amazon Web Services. So today I'm going to talk to you about a new IoT service that was announced in the last reInvent a few months ago called AWS Greengrass. So I have roughly 15 to 20 minutes, I think. So if we do not get to any Q&A, I'll be around after the session, around networking. So please come and talk to me if you want to know more. It'll be more of an introduction level talk with the time we have. So happy to take any questions or any deep dives after that. So before I get into what Greengrass is and what the typical use cases we see around Greengrass, let me just give you a very quick context around this, in terms of how we arrived at, sort of announcing this service. So I'm sure you'll agree, IoT generally is one of the big mega trends. It's recognized by a number of different analysts. We have millions of devices being connected, and the prediction is there'll be probably billions of devices in the future, in not too much in distant future. So to address the IoT challenges, to address the IoT use cases, we had launched IoT Service, which is a cloud-based managed service back in 2015, which a lot of customers use for a lot of different interesting use cases. But we've been also hearing that there've some use cases which are quite challenging, in terms of using a cloud-based service with the latency and some of the other issues that can arise, typically when you have environments like these. Just think of a scenario like a mining site where you have, mining truck with a number of different sensors, for example. The internet connectivity may be very poor at best, or sometimes, there may be a lot of problems to be always connected, or the bandwidth may be an issue in some cases. Again, think of things like an oil rig in the middle of the ocean, which probably has a very weak satellite link, for example. So there are certain use cases where being always connected is not possible. And this problem is not going away, because besides the law of physics of, you can only move as quick as speed of light, so there are latency problems. But in some of these use cases, you need to make a very quick decision. I mean, think of connected car, for example. If the car has to make a very quick decision within a fraction of the second, the latency is not going to help. And then besides the latency, there are law of economics. Sometimes it may not be economically feasible to send and stream every single data packet which is coming out from your devices. Because some of this data, probably you only need to make some local decisions, and some data is probably best going into the cloud for doing some analytics, for doing some machine learning algorithms, for example, do things like predictive analytics on your IoT devices, but probably not for every single piece of data in certain use cases. And then there are also law of the land. So in some use cases, you may be you may have some regulatory requirements around what you can and cannot send out of these sites, for example. So as we see IoT, there are really three key pillars around IoT. So on one hand, you have the things. These are the devices, the IoT devices, the sensors that gives you the telemetry information that act upon the telemetry or the sensors, the information that these sensors gather. Then we have the cloud bit. That's where our IoT service works. So cloud gives the ability to store all this massive data which IoT devices are collecting, do some compute. And then finally, it's not just about collecting and storing data. You need to make some sense out of that data. So this is where analytics, things like machine learning, things like big data analytics really help you to draw the value out of the data which these devices are collecting. Now, for those of you who have seen IoT service before, or have some understanding of how AWS IoT service works, this is kind of a logical view of how the IoT service works in the cloud. So at the heart of it is a device gateway, or it's also called a broker. This is responsible for communicating with the devices in the field. So all the devices send the data into the cloud through this device gateway. And then we have number of security features. It's based on a mutual authentication. So devices and the device gateway, IoT broker, sort of mutually authenticate each other. Then some of the other important components are the rules engine, where it shows actions. So what do you do when all this data arrives in the cloud? Using rules engine, you can stream this into different AWS services. This is where it makes really easy for streaming this data from IoT into other AWS services, which could be Kinesis, could be Elasticsearch. If you want to later on search this data, you can stream straight into DynamoDB, or you can do machine learning, for example. There are a host of other services that you can integrate with rules engine. So you can do filtering and integration with other AWS services. Then another important concept here is of device state, or also called as a shadow. So this is how you can, in an offline way, know what the current state of the device is. So if it's some sort of an engine, you will know, is it on or off? And then using this concept of device state, you can also remotely control the device. So when you update the state in the cloud, it gets reflected, device knows its state needs to be changed, and it takes an action. So all this framework that you see here, basically with Greengrass, we are taking it on the edge. So Greengrass essentially is a binary runtime that you can run on the edge, and with all the goodness that you've seen with the IoT managed service. So you'll have a local device gateway, you'll have a local device state, and all the goodness of security that we've built with the IoT service, now you can also deploy with Greengrass. And also, you can run Lambda on the edge with this. So remember the initial use case I was talking about? What if you need to make some quick action, you need to do some processing with this telemetry locally in that local environment with a local network. So by running the Lambda on the edge along with the rest of these components gives you that flexibility and then benefit. So as I said, Greengrass is a software, it's not a hardware. You deploy it on your hardware. It could be devices like a Raspberry Pi, for example. It gives you ability to run local logic with the Lambda, which is available as part of this framework. You manage the security, access, and also Greengrass will manage and sync the state for you with the cloud and the device. So whichever frequency you choose to do so. Because you may want to actually send data at some point to the cloud so you can do some compute and some analytics in the cloud. So in terms of the key benefits you get, you respond very quickly to the local events. You have ability to operate offline, so you can actually bring the same logic which you have probably written in Lambdas in the cloud, and you can bring the logic and now deploy with the Greengrass on the device itself. It makes the device programming very simplified, because effectively what you're doing is the same skills that you've learned how to do Lambda in the cloud, for example, you can bring the same skill and deploy that on the device without necessarily knowing the embedded programming, for example. So you have the same programming model that runs on the device. And also you can reduce the overall cost of IoT applications, because what now you can do with these Lambdas on the edge, you can do aggregation of data. So rather than send every single stream, every single data packet into the cloud, you can collect them, you can bash them, you can do some aggregation, you can do some filtering, and then choose to send only relevant data which you think makes sense to go in the cloud. So let's very quickly go through some of the key components of Greengrass. So there are really two parts of Greengrass. One is Greengrass Core. This is what runs all that framework we were looking at. And then there's also IoT Device SDK, which is to some extent similar to the existing IoT SDK, but we have added a few bits onto that to make it talk to Greengrass as your local IoT broker, and in addition to what you already have in terms of talking to IoT backend in the cloud. So, as I said, Greengrass Core is a runtime. It's responsible for execution of Lambdas. It is responsible for managing the messaging between either within the device where the Greengrass Core is running, or you can have a local network of the device. So for example, again, if you talk about something like a car, there are going to be a bunch of different sensors. There could be many different microcontrollers where these sensors are attached. But you can have probably either one device, a central hub device in a typical hub and spoke model where you run Greengrass Core and manage all that ecosystem of devices in your local environment. Or it could be a mining site where you can have different type of sensors, maybe sensors on the trucks, sensors on the drilling machines, etc. And you can form that local ecosystem utilizing local network and local devices. So Greengrass Core manages that. There's some minimum requirements in terms of for the device to be able to run Greengrass Core. It needs to be minimum 1 gigahertz, 128 MB RAM. It supports x86 and ARM architectures today. There'll be more probably added in the future. And also we've tested this with Ubuntu and Amazon Linux, and probably more flavors will be added in the future. This is what is available in the preview. But by all means, you can test on different Linux flavors as well. And really, because Greengrass is only restricted by the resources which are available on your device. You know, if you've got bigger device, you can do a lot more than, you know, with the compute, memory, and storage available from your device. IoT SDK is something you will typically run on your endpoints, the end devices or the microcontrollers. And this is something which you'll use to communicate back into the with the Greengrass Core and send the telemetry or the information these sensors are collecting. It's available in C++. Again, more languages will be probably added in the future. And so these devices can connect to Greengrass, and you know, it could be microcontroller, as I said, or it could be full-fledged devices like Raspberry Pi and others. Also, what you can do with Greengrass, you can form a set of cores, or what is called as a device groups. So if you have multiple devices, you can have multiple gateways, or you can have one gateway and multiple devices connecting to this gateway. So really up to you how you lay out that local device topology based on the devices you're using and based on the use case and the problems you're trying to solve. But Greengrass, the core will help you manage this mashup of devices locally. And also, it's not just managing the local devices, it'll also take care of talking to the cloud in the background and making sure you can sync the states and the data with the IoT cloud as well. So you can get started. You can go to this link and register your interest for preview if you want to try it out on your devices. And I think that's about it. Did I make it on time?
Brilliant.
Thank you.
Thanks. Thank you very much. I'm just cautious about time, so I'm just going to introduce our final speaker, who will come along and talk about CI and CD. While he's setting up, we've got a raffle at the end of the evening, so we should be wrapping up about 8:30. The food will arrive shortly. I appreciate